This lesson is about increasing and decreasing functions and using the first derivative test. First of all, we all know what increasing and decreasing functions are, but to formally define an increasing function, let's just take a look at what we know when an x value, x1, is less than x2. So for example, if I were to plot a point, let's say down here at 2, and then another point up at 5, and if the output, or f of x1, is less than f of x2, this implies we have an increase in the function. So that's the definition of increasing. Okay, so then to define decreasing formally, if we're looking at an x value that is less than another x value, let's say again I'm at the point 2, but now my output is up here, and then I go up to x2 at 6 and my output is down here, we know that that is a decreasing function. So decreasing is whenever the output of x1 is greater than the output of x2. So that's just the formal definitions of increasing versus decreasing. Okay, so to test if a function is increasing or decreasing over a certain interval, we would say, let f be a function that is continuous on some closed interval a, b, and differentiable on the open interval AB. So with this condition, if function's derivative is greater than 0, and this is already a connection that we know, if the function's derivative, so f prime of x, is greater than 0, then we already know something about f. So think about what that is. It's that f is increasing. Okay, so again, if we have a, positive derivative, we already know that implies that f is an increasing function. All right, secondly, if the derivative is less than 0, then we already know what this implies for f. F is decreasing. So again, negative derivative would imply a decreasing part of the function. And then finally, if the derivative equals 0, then we know at that point f is neither increasing nor decreasing, it is constant. So 0 derivative implies that the function f is constant. Okay, so just to kind of sketch a little picture of what that looks like, we know that any function's graph where the derivative or the slope is negative, that implies the function is decreasing. If the derivative or the slope is 0, that implies that the function at that point is constant. And then finally, if the derivative or the slope is positive, that implies that the function is increasing. Okay, so let's go back. Moving on to the next part, we're going to do an example of how we can use the derivative to test the intervals over which a function is increasing or decreasing. So here's the steps that you're going to be using. You first want to make sure that you find any critical numbers, okay, which we've practiced. So find any critical numbers. So this means figure out the derivative and figure out when the derivative either equals 0 or when the derivative does not exist at a point. So that's what we're trying to determine. The second step is going to be to make a sign chart. And you'll see what I mean by this in a little bit. So you're going to make a chart. And you're going to make a sign chart to indicate when the derivative is positive and when the derivative is negative. And then lastly, we're going to determine the sign of f, which is what I just mentioned. Excuse me, the sign of f prime. Okay, so using these three steps, let's look at an example. First of all, we're given this function x cubed minus 3/2 x squared. And let's say I want to find the intervals of increase and decrease. So the first thing I need to do is find the critical numbers. So how do we do that? We'd find the derivative, so f prime of x equals 3x squared minus 3x. Okay, to find these critical numbers, I need to determine what would make this 0. We can factor out a 3x, and I see that my critical numbers are at 0 and 1. Now that we have those critical numbers, we're going to set up a chart. So this is that second step. So my chart is going to be broken up using those critical numbers as breaking points in my interval. So I'm going to go all the way from negative infinity until we get to that first critical number. Now that first critical number is 0. Then I'm going to look at the next interval, which is from that critical number to the next critical number, which is 1. And then finally, my last interval would be from that critical number 1 all the way to infinity. Okay, so over these intervals, you want to pick some test points. So I'm going to go ahead and label that just TP for test points. So I want to pick points or values of x that are within those intervals. So something between negative infinity and 0, I would just choose, let's say, negative 1. Something between 0 and 1, let's choose 1/2. And something between 1 and infinity is 2. So those are my test points that I've chosen. Now what I want to do with those test points is I want to evaluate them at the derivative. So f prime of each of those test values. So go ahead and take negative 1 and substitute that in for the derivative. When you do that, you'll end up noticing that you get a positive number. So this is where we're going to be evaluating our signs. So we got a positive number for f prime. Okay? Actually, let me make this in red so I'm color coding everything. So positive for f prime. Go to the next value. If you substitute 1/2 in for the derivative, you'll notice that we actually get a negative output. And then when you substitute in 2 for the derivative, you would see that we get a positive outcome. Okay, so using this information, what we can conclude about f, so we're just going to add a third part to our chart, what we can conclude for the interval from negative infinity to 0, I know that my function is increasing. From the interval between 0 and 1, I can say that my function is decreasing. And then finally, continuing on from 1 to infinity, I know that this function is increasing. And in fact, if you want to type the function x cubed minus 3/2 x squared into your graphing calculator, you would see what this function looks like, and you should be able to identify this. So the way we would just write our answer, you would want to say the intervals over which it's increasing and decreasing. So you would say f is increasing, and then you would just state the intervals. So -infinity to 0, and then also 1 to infinity. F is decreasing over the interval from 0 to 1. Okay, so that's our first example.